trapping rainwater. The question is, given a non-negative integers representing an evaluation map where the width of each bar is 1, and compute how much water it can trap after raining. So we can see the height is stuff from this means 0, and this means 1, and this means 0, and this means 2, and this means 1, 0, 1, 3, something like that. So above evaluation map back section is represented by the array like this. In this case, 1, 2, 3, 4, 5, 6 units of rainwater, blue section, are being trapped. Okay, so for these problems, we can have something here, so we can use the, let's see, how could we use like, for this one, if I know the current now, right, you can see I can know from the left and the right, I can know this one is 2 and this is 1 is 1. So what I container is current 1, minimum left max and the right max minus current here is what I can get, and plus all of them, right? Okay, so based on this idea, we can use like a prefix array, right, to store the left max, and also the right is called suffer. Start from the right to maintain the right max, and the result is the plus, right, current container. Result is the maximum, minimum, because how many waters can contain is based on the minimum part, and the right max minus current height. Current height here. So based on this idea, we can do like a, it can use like TC is like ON time to look forward and go back and calculate, right? And for the space, I need to create an array to store these numbers. This is main idea about this way. So let's see. Height, length, int prev new int. Yeah, it's an, and the pre-sub, right? So we can start from this one. Int left max, I can handle from the links the 0 here, and prefix 0, it should be the height 0. Now we can use like a for loop to fill this, I would treat it like kind of like a table or the sheet, right? We can start from the 1. Curl height is equal to the height here. And I want to store the r equal to the maximum curl height or the previous one. Then we can update the maximum. equal to the same. Update here. And the same thing for the suffer here. Int right max equal to the -1. Pre the last one is equal to the height -1. Same for loop to initialize this table. We can start from the last one. Last one is already, this one is already initialized, so we can just start from this one. Large equal than 0, I minus minus. And the sub right max, and update the right max. Right max is, when it's finished, we can start this one, right? It's kind of like we can write here. So for this one, start from the left one. Current now it should be 1 and 2, 2, 2. This start from the 3, so here is 3, 3, 3. And for the right part, we can start here. It start from this one, right? 1, 2, so this one is 2, this one same. Oh, encounter 3, so current 3. Here 3, 3, 3, 3. So it seems like before we encounter here, right? You can see this one is based on the left one. It's true based on the left one. So you can see here current is 1, right? 2 minus 1 is equal to 1. And 2 minus 0 is equal to 2. So based on this. And same for here. So pick up the minimum of them. Now we can start here. At the result, we can initialize 0. And for int I, start from 0. Curve pref. Curve suf. Right. And then what we can do is like pre I, suffer I, so and also current height. Curve equal to the maximum of them, or minimum of them. Curve brace self. Curve self. And current, how many it can contain, is equal to the curve minus current now is the like this one, right? So current curve minus current height. And the result, if the contains is larger than 0, which means we can get some water. Like if current here, you can see the left is 3, right? Current here, the minimum one is 3. So 3 minus 3 is 0. So which means no water. So if larger than that means have water, so we can update the result. When it's finished, we can return the result. Let's see. Oops, next curve right. Cannot convert to the, oh, this is here. Yep. Let's see. Okay, it works, and for the time complexity is let's say here O(n)(O)(n) time. See here. Yep. This is one solution to solve these problems. And we can see this time we cannot, at least we have to scan it for one time. So O(n) time is has to be, and for the space, right? Whether we really need this thing, because we already scan it, right? So it's kind of like lots of things, like current here in this way, we actually don't need this one, but we still store the some information about this. So I think the space can be improved. We just focus on, like, if I calculate for here, I just only need like this one, or very, it's like I only just need the neighbors information, not the whole thing. So we can improve from the space. So let's see. So for the space, we can use 2-pointer to do that, right? So current now, I just focus on like how many, this one, and this is left and this is right. So I just need to know the left maximum or right maximum and pick up the minimum of that, and I can calculate current now. So that is the main idea about this. So we can start from here and here to just pick up the minimum, right? 1 is 1, okay, so we can start here, and for this one is 2, and we keep moving, here is 2, and they are same, so we can move here. Here the left and the right stair is equal to 2, so just only 1. Okay, so current now, this one is larger than this one, so we can move, here is 3, and for here, okay, so stair is got 3, so we can calculate for here, and for here we can keep moving for this one. So just to focus on the small part. It's like a bottle, right? We can focus on the small part, then we can calculate current now, how much it can contain the water. So like a 2-pointer to solve these problems. Left max equal to the right max equal to the height minus 1. Oops. Okay, we can, we don't need that. Suppose the left max is equal to 0, and the right max is equal to the 0. So wire the left equal to the right. When I encounter like current now, we still need to calculate. So it should be true. So if I come here, right, so left max, we should update the right max equal to the max. If the left max smaller than the right max, so right max should move. Right, so if the left max smaller than this, so we can calculate for the left part. We also need the result. Plus if they are same, so only way is left max is larger than that, it can, yeah. And for here we can right max minus height. If they are equal, no matter who move, right? So return results. Oops, okay, run. When is gonna be? Oh. Right. Right should be the. It's always 0. Left max is equal to 0, right max 0. It's fine because we will update here. Okay, so I think the bigger one should be move, yeah. We start from here, right? This already update. Okay, let's see what's going on. We can debug here. Alright. right is 11 here, right? So right max is equal to 1. Right max is larger than this one, so right max should be 2. The right should be 9. Okay, this see. Okay, right. You can see here, right? It's moving here. This is 2, and we come here. This should be the left, right. No, should be what? Yeah. And for the time complex, they should be the TC is O. We have to at least to scan one time space. We didn't create extra space. Yep. Okay, so for this one is like we have to make sure on the left maximum and the right maximum. So pick up the minimum of them and to calculate this one, right? Like for example, current here is like current here is 2 for here, right? It should become 3 here. So we should move for the left one, move here to calculate. So this is means left max is smaller than this 3, right? So we need to result is left maximum minus current here to add this one, this water block, and the left move here. The left max there is equal to 2, so we can calculate for this one. And until here and until they are encounter left and right. Yeah, this is the main idea about this one. Yeah, and thank you.